In today's lesson, we will learn about the Stokes Theorem. So previously, we learned about the Green's Theorem, which let us turn the line integral for a closed curve C in the two dimension into a double integral. Today, we will learn about the Stokes Theorem, which we can say as a higher dimensional version of Green's Theorem. When we have a closed curve in 3D, closed curve where the curve is the boundary of the surface S, just as with Green's Theorem, we assume that the curve is positively oriented, which means the path of the curve give in the counterclockwise direction. With respect to the normal vector of the surface. In other words, you can say that the Stokes Theorem relates the surface integral over a surface S. Okay, this is surface S. Surface S must be in three-dimensional. Relates surface integral to a line integral around the boundary curve of S. Okay, where is the boundary curve? Here, C. Okay, C is the boundary of curve S. So the orientation of the surface S will induce the positive orientation of C. So to get the positive orientation of C, think of yourself as walking along the curve. Okay, let's say this is the curve. Okay, so if you walk in the positive direction around C, okay, so your head pointing in the direction of N. Okay, so this is your N. The surface will always be on your left. This is similar to the right hand rule, where when the thumb points in the direction of N, the fingers curl in the forward direction around C. If we have a vector field, to find the amount of the field that goes in the direction of the curve, we need to take the line integral of F along C. Stokes' theorem gives us another method of finding this line integral, which can lead to a simpler calculation. So the theorem states that the line integral of F along C is equal to the surface integral of the curl of F dot N over surface S. So we have discussed how to calculate surface integral in the previous lessons. So we have seen that they are not too difficult to solve. It's just that now we have extra step of taking a curl. So remember that the curl of a vector field is calculated by taking del cross F, where del is a vector. Okay, del X, del Y, and del Z. This is how you find your N for cylinder and sphere. Del S over magnitude del S. And then for a N, normal vector for non-parametric surface, so you can just use this table that we have used in the previous lesson in the surface and volume integral. So how to know the N is positive or negative? The N vector for any closed curve always point outwards of the surface. This is the definition of Stokes Theorem. Okay, so the left hand side here is the surface integral of a curl vector field. Okay, where S is a surface in 3 dimension, and the right hand side is the line integral around boundary of a surface. So let's say you have this. This is your C, and this is your surface S. So your N should be this. direction. The first step is to sketch the region or the diagram. Okay, this is very similar to the Green's theorem. And step 2, if the question asks you to verify or to prove, you have to calculate both sides. And if the question asks you to evaluate, calculate one side only. If the question asks you to evaluate f dot dr, so you have to calculate this part. Example 1, verify Stokes theorem for the vector field f 2zi plus 3xj plus 5yk, taking s to be a portion of the paraboloid z, okay, 4 minus x squared minus y squared, for which z is greater or equal to 0 with upward orientation, and c to be the positively oriented circle that forms the boundary of S in the xy plane. Okay, so this is your C and this is your surface S. To verify the Stokes theorem, you need to show that the left hand side is equal to the right hand side. First step is to sketch the figure. Okay, so this is your figure. This is your F, and this is the definition of Stokes theorem. So I want to solve the left hand side first. We need to find the curl F. Okay, now you need to solve the curl F. So for the first component I, okay, you need to differentiate 5y with respect to y, so you get 5 here, minus to the differentiation of 3x with respect to z, so you get 0. Similarly, okay, minus j, okay, differentiate 5y with respect to x, you get 0. Differentiate 2z with respect to z, we get 2. Okay, and then the third part for k, okay, differentiate 3x with respect to x, you will get 3, and differentiate 2z with respect to y, you will get 0. Simplify this, you will get 5, 2, 3. You have to find your n. So n is in the positive direction, so just refer to the table. So you have to find this value from the equation. Z is equal to 4 minus x squared minus y squared, so differentiate this z with respect to x minus del z del y plus k, so you will get 2x 2y 1. So this is your curl F and this is your n. Before you integrate this value, you need to change this x, y to the polar coordinates. So your x will be r cos theta, your y will be r sin theta, z is equal to 0, and ds is equal to r dr d theta. Just solve this surface integration. Simplify this, okay, do the dot product, then you get this value, and then integrate with respect to r, you will get this value after you simplify, and then integrate again with respect to theta, and then substitute the upper and lower limit, simplify, and you will get 12 pi. So this is the answer for the left hand side. Now let's do the right hand side. The line integral f dot dr, so t will be from 0 to 2 pi because of the paraboloid. So the boundary is the full circle here will be 2 pi. This is equal to 360 degree. Solve the line integral. So you have your r is x, y, z, and then change this to the polar coordinates Okay, because we have a circle here, so x is 2 cos t, y is 2 sin t, and z is equal to 0. And find your dr dt. You get this value, so your dr will be negative 2 sin t, 2 cos t, 0 dt. So this is your f, and this is your dr. Now let's solve this. Simplify. After dot product, you get this value. Simplify it. Then you need to change this using trigonometric identity. Cos squared t is equal to 1 plus cos 2t over 2. So after we change this, you can solve the integration. Okay, integrate with respect to t. You get 6 times 2 pi, so this is equal to 12 pi. So you can see that the left hand side is equal to the right hand side. So the Stokes theorem is verified. Example number 2, given that S is a combination of surface, S1, this surface S1, S2 and S3 at the back here. Okay, S1 x squared plus y squared equal to 9. Okay, this curve. Okay, and then S2 z equal to 4 here. Half of the circle with radius 3, and S3 y equal to 0, this surface. So if f is equal to zi plus xyj plus xzk, show that curl f dot n ds is equal to 18. So you need to find this curl f dot ds, and this is your f. So just solve this curl f, and you will get 1 minus z j plus yk. Then we need to integrate each part of the surface. Okay, S1, S2 and S3. So S1 surface x squared plus y squared equal to 9. Okay, this is the surface S1. So this is a half circle. So your n will be del S1 over magnitude del S1. Okay, so this is your del S1, and then you can find the magnitude. You will get 6. So your n will be xy0 over 3. And then find curl f dot n. This is your curl f, and this is your n. Okay, solve the dot product and simplify. So you will get 1 over 3y times 1 minus z. So by using polar coordinates of the cylinder, okay, because S1 is part of the cylinder, so you have to change to the polar coordinate of cylinder. Okay, where your phi is from 0 to pi and z is from 0 to 4. Okay, so curl f dot n will be sine phi 1 minus z. Okay, so you need to solve this, then you will get negative 24. For the second surface S2, surface z equal to 4. Here z is equal to 4. So since it is positively orientation, so we just use this formula. Okay, this formula n from the table. So you will get your n is equal to k. Okay, so now by using polar coordinates of a plane, okay, y is equal to r sine theta, z is equal to 4. R is from 0 to 3. Radius of this half circle is 3, and then the theta is from 0 to pi. So half circle like this will be 180 degree. This is equal to pi. So that's why we get this boundary. So this is your curl F and this is your n. Solve this, we get r sine theta, and then find the integration of curl F dot n ds. Okay, this is curl F dot n and this is your ds. Okay, theta is from 0 to pi and r is from 0 to 3. Okay, solve this, then you will get 18. For S3, y equal to 0. This surface at the back, you can see here the arrow will be like this. So if you apply the right hand rules, you will get the n is pointed here. Okay, so it is negative oriented. So just follow the table using this formula. So you get negative j. So ds is equal to dx dz, and the integration limit, okay, for this surface, okay, x is equal to negative 3 to 3 and z is from 0 to 4. So curl F dot n, this is curl F, this is your n, so you get z minus 1. Okay, just do the simple integration here, solve it, then you will get 24. The total integration for S1, S2 and S3, so your final answer will be 18. So you just solve the both sides of the Stokes theorem. Okay, that's all. Thank you.